here at Nehru Science Center, we are celebrating World Space Week. And October 4th is the date when we started this celebration. We are having several programs going on. And why October 4th? Because that's the day in 1957, on October 4, the first human-made satellite was launched. So, to commemorate that success and opening of a new chapter, October 4th till October 10. Again, why October 10? October 10 because that's the date. 10 years later, October 10, 1967, it was a treaty that was entered into and for the peaceful uses of the space exploration. So, October 4 to 10 is celebrated as World Space Week. And we have Nehru Science Center, which is a unit of National Council of Science Museums, has joined hands with Space Geeks and the Indian space industry exhibitors to organize various lectures, series of lectures during this particular week. And today we have the first lecture of the series, and our acting director Sri Arnab Chatterjee is also joined, and the speaker is also joined. So I request our acting director Sri Arnab Chatterjee to please welcome all and also to introduce today's chief guest, the speaker.
Thank you, ma'am. Thanks for the introduction. Before I start, I'd like to welcome you all once again, those who have joined with us virtually. And it's an enormous opportunity for us to listen to Dr. Anil Bharadwaj. You all know he is a famous personality in ISRO as well as in our national space programs. I'll briefly introduce him before we formally hand over we start the talk formally. And okay, so to start with, Dr. Anil Bharadwaj received his MSc from Lucknow University in 1987 and PhD from IIT BHU in 1992. He joined ISRO in the year of 1993 as a scientist at the Space Physical Laboratory (SPL) of Vikram Sarabhai Space Center in Trivandrum. He became the head of the newly formed Planetary Science branch of SPL in August 2007 and was subsequently the director of SPL during February 2014 to February 2017. Currently, he is the director of Physical Research Laboratory, which functions under the aegis of ISRO, or Indian Space Research Organization. He has worked at NASA Marshall Space Flight Center, USA for about 2 years as National Academy of Science Senior Research Associate during 2004 and 5. Dr. Bharadwaj initiated the research in planetary science at SPL and contributed to the development of planetary science program in ISRO and Department of Space and planning of planetary missions of India. He was the principal investigator of SARA experiment on the first Indian lunar mission, which we all know as Chandrayaan-1, which has revolutionized our understanding on the interaction of solar wind and with the moon through several new findings. This is just a brief introduction. Let me tell you even more about the prizes, the honors he has received. Dr. Bharadwaj, just a minute. Yes, Dr. Bharadwaj has received several awards and honors, including the most coveted Santi Swarup Bhatnagar Prize in 2007 and the Infosys Prize in Physical Sciences in 2016. His various other awards and honors include Nehru Centenary Lecture of Kerala Academy of Science in 2007 ISRO Team Achievement Award for the Chandrayaan-1 in 2008, Indo-Swedish Project Award from Swedish Research Council in 2010, Indo-Swiss Joint Research Program Fellowship in 2010, ISRO Merit Award in 2012, AOGS Planetary Science Distinguished Lecture Japan 2014, Dr. P.R. Pisaroti Memorial Lecture of the Kerala Science Congress 2015, INSA Vainu Bappu Memorial International Award 2016, Decennial Award of Indian Geophysical Union 2017 and Lunar and Planetary Society's Endowment Lecture of Gujarat Science Academy in 2018. Uh, the Indian Institute of Technology (DITU) conferred the first Distinguished Alumnus Award on him in 2015. ISRO honored him with the Outstanding Achievement Award, highest award of ISRO in 2017, and Uttar Pradesh state government felicitated him for distinguished work in space and technology during the first UP Divas in 2018. He is awarded the J.C. Bose National Fellowship Award in 2019 and Professor M.G.K. Menon Lecture Award of the National Academy of Sciences, India in 2021. These are just a few awards to say, even there are a number of them in the list. So, without standing between the audience and Bharatwaj sir, I'd like to hand it over to Bharatwaj sir. Sir, the stage is open for you.
Thank you, Dr. Arnab, and thanks to Manju and all the Neuroscience Center colleague for inviting me to this lecture series, which you have started as a part of the World Space Week. So, first of all, welcome to all the audience and those who have joined us live on this lecture. I'm going to talk on the Indian planetary missions, which is essentially a very hot topic now with after the success of the Indian Chandrayaan-3 mission. And what I'll do is to give you glimpses of what has happened in the past in the country, how things have happened, what all we have done, and what we have achieved and what we plan to do in the future. But before we start, let me just confirm that my voice is going clearly to everyone and the slides are clearly visible. Can anybody confirm?
Manju ma'am, can you please confirm it from those who have joined over
Yes,
Facebook?
yes, it is clear, sir.
Okay.
Everything is all right.
Perfect. Thank you. Thank you. So, as you must be seeing on the slide, that I belong to Physical Research Laboratory in Ahmedabad, which is one of the oldest institute in India, and it is also called as cradle of space science in India, because it was established by none other than father of Indian space program, Dr. Vikram Sarabhai. And any activity which started in India started under the leadership of Dr. Sarabhai, because he established this institute called Physical Research Laboratory in the year 1947, just a few months after we became independent. So whether you talk about rocketry program, satellite program, ballooning program, or any space research activity, it all started here in this Physical Research Laboratory. And in this picture, you are seeing Dr. Kalam, Dr. Abdul Kalam, standing along with Dr. Sarabhai, and on the rear side, you are seeing Dr. Madhav Nair, who was later on the chairman of ISRO. And if you talk about the first rocket launch, which happened in 1963, the 21st of November, from Thumba, which is now called Vikram Sarabhai Space Center, it also had an experiment developed in PRL and launched on the satellite. So 1952, we have actual foundation laying ceremony of this PRL campus, and it was done by Sir C.V. Raman, because the Nobel laureate of India. Dr. Sarabhai used to consider C.V. Raman as his guru. And in 1954, we had the inauguration of this building, which you see over here on the right top side, which was done by Pandit Nehru, the Prime Minister of India at that time. And currently, you are seeing how this building looks like. It has maintained its same structure, which was there in 1954. PRL also has a campus close to the main campus, which is about 5 kilometers from here, which is called Thaltej campus. But we have two more campuses of PRL, one in Mount Abu, which has a telescope, and the other one is in Udaipur. You see in the middle of the lake, you see the observatory, which is the Fateh Sagar Lake, and that is called Udaipur Solar Observatory. So essentially now this Mount Abu observatory is further upgraded. We have another 2.5 meter telescope also at this observatory now. So you see there the two telescope, one 1.2 meter, other one is 2.5 meters. Now talking about Dr. Sarabhai actually has a crater on Moon, which is seen over here in this image, which is taken by the Chandrayaan-2 terrain mapping camera. And this crater is on the near side. of the moon. So one can actually see this crater with the help of a small binocular or a small telescope essentially, because it is at around 24.7 degree north and 21 degree east, and it is fairly big. It is about 8 kilometers in diameter and about 1.7 kilometer deep. Now, let me talk a little bit about the solar system before I go into planetary missions. So if you look at this slide, you will see that there are two class of planets in the solar system. One which is closer to the sun, that is Mercury, Venus, Earth, and Mars. They are called inner planets, rocky planets, or terrestrial planets. And then there are four big planets, Jupiter, Saturn, Uranus, and Neptune, which is in the outer part of solar system. Let me tell you that this is not plotted as a function of distance, but just to tell you about the relative sizes. Also, we have small bodies in our solar system like asteroids, comets, and things like that. They all constitute the whole solar system. And if you look at these two, you will see that the inner planets are quite small and they have very few moons, like Earth has one, Mars has two, Phobos and Deimos. But if you go to the outer part of solar system, there is very large number of satellites, and some of them are even bigger than the planet size itself. For example, Jupiter's biggest moon, Ganymede, which is the biggest satellite of solar system, it is bigger than the size of the Mercury and Pluto itself. Now let me compare this terrestrial planet to give you a feel of how big they are. So Venus is roughly the size of Earth, Mars is roughly half, Mercury is 1/3. But when you go to the outer part, you will say that Jupiter, of course, is the biggest, Saturn is second, third is Uranus, and then Neptune. Earth is the fifth largest planet in our solar system. But when you compare this with respect to Sun, you see that Earth is a small dot. So that means, and on this dot, you can imagine where India is, where Mumbai is, and where you are, right? So the size of the objects matters because they also governs the gravity, and the planetary system is based on the gravitation. Now let me go quickly to tell you that the advances in the planetary exploration within the country is all possible because right now we have the capability to launch our own developed satellites by using our own launch vehicle from our own soil. And this capability has been built up into the system starting from Dr. Sarabhai starting the rocketry program in Thumba. You just saw that 1963, 21st of November, we had the first launch from Thumba. And slowly we built up the bigger rockets like SLV-3, ASLV, and PSLV, which is basically the workhorse of India and ISRO, because this has done many versatile launches, including the Chandrayaan-1 launch, the Mangalyaan launch, and very recently the Aditya launch. And the most heaviest, or you should say the Bahubali rocket, is the GSLV Mark III, which has a 4-ton capacity into GTO, and which has been used very recently for launching the Chandrayaan-3, as well as, of course, the Chandrayaan-2 mission. Now, let us go to how the exploration has been happening for the moon, which started with the Chandrayaan-1 mission, followed by Chandrayaan-2, and very recently Chandrayaan-3. Of course, they are a bit far apart. We had the first launch in 2008, the second Chandrayaan in 2019, and Chandrayaan-3 in 2023. And when you talk a little bit more, let me show you how things have been moving. So when you talk about Chandrayaan-1 mission itself, it is one of the very versatile missions. Launched on 22nd of October 2008 and reaching on moon on 8th of November 2008 after 16 days of travel. It consists of 3 payloads or 3 experiments which were being flown for the first time in the exploration of any planetary body. And it has 11 experiments on board. You can see much better over here, where you see also a small box sitting on the top, which is basically gray object sitting on the top, and which is called Moon Impact Probe. And this Moon Impact Probe was the one which was released after we reach 100 kilometer circular polar orbit to land onto the south pole of the moon. And this has actually made this MIP, the Moon Impact Probe, as the first man-made object from India to land into the polar regions of the moon, and which happened on 14th November 2008, right? So almost like 15 years back, we had landed an object into the polar regions of the moon. But of course, it was a free fall, so it was like a crash landing. Right? Now, there was a lot of science which has come out from the Chandrayaan-1 mission, which includes, of course, the discovery of water. Till that time, we are all thinking moon is going dry, there is no water, but Chandrayaan-1 mission of India has showed that water exists on the moon. It is there on the surface, below the surface, and above the surface. And it is much more in the polar regions. We also validated the lunar magma hypothesis, discovered mini magnetosphere, the smaller size magnetosphere, and we also told that moon is geologically active. It is not a dead body. There are volcanoes activities which has happened in the recent past in a geological time scale of like 100 to 10 million years, tectonically active, and of course the water on the moon. And we also learned a lot about how solar wind interacts with the moon. And there are many publications, more than 200, some of them actually making the cover pages of the very important and well-known journals like Science and Geophysical Letters. Let me show you this movie, and please tell me if you are able to see this movie. And this shows you how the surface of the moon actually looks like. I hope you can see this movie, which is playing right now. Okay, great. So this is how the surface of the moon looks like. And this is from the Chandrayaan-1 mission, the first Indian lunar mission, right, in 2008. And this shows that the surface of the moon is filled with craters of all possible dimensions, and there's albedo changes, there are hills and valleys and things like that. Now I will jump quickly to the Mangalyaan, that is the Mars orbiter mission, which is the second Indian Planetary mission. And in the bottom, you are seeing the spacecraft on the left bottom. In the middle, you are seeing a big antenna. This is a 32-meter size antenna, very close to Bangalore in Bengaluru, which is called Indian Deep Space Network, and which was used to communicate with the Mars because the distance is so large. And of course, the GA and the PSLV rocket on the left bottom, the right bottom, which was used for the launch of the Mangalyaan. This mission, which we had the launch on 5th of November 2013, which was the 25th successful launch of the PSLV, that is the Polar Satellite Launch Vehicle. And after 10 months of travel, we reached the Mars on September 24 of 2014. The lifetime of this mission was just 6 months, but it lasted for more than 8 years. And that is what the beauty is, that the capability which is existing within the country, we could do that. But the more important part is that India is the first country in the world to have the successful insertion of an orbiter around the Mars in the first place. So there also we have made a history. And this actually carried 5 experiments on board, which you see over here, like LAP, MCC, MSM, TIS, and MANCA. And MANCA as an instrument where I was directly involved. And this is how you see the whole spacecraft sitting on the top of the PSLV launch, and you see the 2 heat shields on the sides. We had the fantastic launch on 5th November in the middle of the day. And what is coming out? We are seeing the full disk images of the Mars. You see here the whole disk of the Mars, the North Pole on the top, South Pole in the bottom, little bit of freezing because of cold temperatures. And if you look at certain features, for example, this one, which is actually the Valles of Marineris, the biggest canyon of the solar system. And it is filled with what? Dust and clouds. So dust and clouds are also very essential aspect of the Mars. And here you're seeing the clouds shadow falling onto the surface. You can also see superficial features, or you can see these features. For example, the Mangla Valley, where one can very clearly see that a fluid flow must have been there. And that is why we say that Mars would have been wet and hot in the past compared to dry and cold currently. That means water would have flown on the Mars in the past. We also talk about distribution of various gases in the atmosphere, and it is dominated by carbon dioxide. But this MANCA instrument told us that as you go up in the atmosphere, somewhere around 250 or 260 kilometers above the surface, this carbon dioxide dominated atmosphere converts to oxygen dominated atmosphere. Also, we discovered superthermal argon, and which is essentially an information which suggests that if we have hot species in the upper atmosphere or exosphere of the Mars, then they are likely to escape faster, and that in turn suggests how Martian atmosphere must have escaped. We also look at the 2 small satellites of Mars, that is the Phobos and Deimos. And this was all possible because of the unique geometry of the Martian orbiter, that is the Indian Mars orbiter mission. So on the left side, you're seeing actually a small black dot around in the circle, which is actually Phobos, and on the right side, you're seeing actually Deimos. Now, when we talk about these kind of missions, we should also talk about Chandrayaan-2 mission, which was of course the much more complicated mission than the Chandrayaan-1 mission because it had a lander and the rover in addition to the orbiter like the Chandrayaan-1 mission. And the launch of this happened on 22nd of July in the middle of the day. And we all know what happened on September 7th morning, that we could not land properly. But the orbiter of this, the orbiter part which you're seeing over here, this is functioning for the last 4 years. And it is with the help of all the instrument on board, it is providing us a lot of new information about the moon, including the OHRC instrument. This is the highest resolution optical camera available on any mission around the moon, and it provides images which is having a resolution of 25 centimeter. And this instrument has been very instrumental in providing us information about the landing site of the Chandrayaan. We also now know much better about the argon distribution, about the sodium distribution at the moon, and also how the water is distributed around the moon, and about the plasma properties around the moon using the DSR instrument or the XSM instrument, which is of course one of the most sophisticated instrument currently available, which is operating, providing us information about X-rays which is coming, or solar X-ray radiation which is coming and falling onto the lunar surface. And the instrument called CLASS is actually looking at this in terms of X-ray fluorescence and getting information about the elemental composition. But this instrument also has seen a lot of flares happening on the sun, and we have seen more than 100 sub-A class flares, or you can say micro flares, which suggests that when the sun is white, which happens as the 11-year solar cycle, there that time itself also sun is active in terms of producing small flares. Now let me quickly come to Chandrayaan-3 mission, which all of you must have already witnessed the landing on 23rd of August evening. We had the launch of this on 14th of July with the LMV-3, and this is the launch vehicle Mark 3 or the GSLV Mark 3 we call. And it consists of the propulsion module, the lander module, and the rover, which are sitting inside the lander. And this experiment, the lander has 4 experiments on board, and the rover has 2. We have a thermal probe called Chaste, we have lander probe called Ramba, we have a seismometer to look at the seismic activity, and of course the retroreflector from NASA. But on the rover, we have the alpha particle instrument and alpha particle X-ray spectrometer and the laser induced breakdown spectroscopy. And alpha particle X-ray instrument is developed in PRL, as well as the Chaste, which was developed jointly with PRL and SPA. So these are the instruments which are worked onto the lunar surface, both on the lander and the rover, and they have all performed very well. And the beauty of this mission I'm going to unveil over a few. So I will not go into details of this. So this mission, as I just mentioned, we had a fantastic launch on 14th of July in the middle of the day at 2:35 hours. And let me see if I have time to run this. I hope I can do that. So I'm going to run a movie of the launch, and in case you are not able to see, just inform me. Okay. I hope you can see the movie.
Yes, sir. Yes, sir.
And-
So normal.
Here we have a majestic lift off.
And can you hear the audio?
Yes, you can.
Okay, perfect.
Spacecraft.
Paper tracking. Regular on Tapu 2000 MDM3 M4 rocket का जो ग्रीन का रॉकेट आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है, हम यहाँ महसूस कर सकते हैं, और यही दहाड़ है जो वैज्ञानिकों को रोमांचित करती है।
So this is the launch of the Chandrayaan-3 mission on 14th of July.
चंद्रमा की यात्रा प्रारंभ हो चुकी है.
And the rocket is moving through the clear sky, every second moving closer to the accomplishment of the most important milestone of this mission to boot.
Okay, so after the launch, there were a lot of people who actually gathered around the Sriharikota, that is the launch point of India. You can see, the crowd. There are almost like 20,000 people around this gallery, which is actually made for public to come and witness the launch. And some of the audience who are actually interested to witness the launch can actually apply online on the ISRO's website and go and witness this launch. But I like this photograph very much, where you see our launch vehicle going up and you can see on the two sides the Indian flag. Now, after the launch, we went into various orbits around the Earth, then we went into orbit around the Moon, and then finally came down to 100-kilometer circle polar orbit, and then had a descent on 22nd of 23rd of August this year in the evening around 6:04 p.m. So I'm now going to show you what happened on that day as we descended, and I will show you a lot of movies which will tell you how our lander actually landed onto lunar surface, and also when the rover came out and started moving onto the lunar surface. So this is just the mission control room, and I'm just showing that I was also sitting there seeing this live happening. So this is me over here, and how the descent actually happened. Okay, so this is again a movie, and in case you are not able to see the movie or hear the voice, then let me know. Okay. So now the lander is coming down, okay, onto the lunar surface, and there's a camera on the lander which is taking these pictures. I don't know how many of you have seen this, because this was actually available on the mission control and MOX in Bangalore. So we were seeing this live, and I thought I will experience this again with all of you together. So this is how we are coming down. We are somewhere around a kilometer above right now, and we are quickly coming down. And these are the craters which you are seeing on the surface. So moon is actually full of craters of all possible dimensions, and you see here all these are craters. So OHRC instrument on Chandrayaan-2 has actually helped us to select the landing site for the Chandrayaan-3, which is relatively free of this kind of craters. And we are slowly coming down, and very soon you will see this all images will stabilize. And that was the time when the Chandrayaan-3 was actually hovering, looking for the best site, because it is an autonomous landing, no command control given from the ground. The lander has to decide of its own where to land, what to do. Okay, we are all coming down. You are seeing bigger craters. You see the black big ones, and soon you will see the velocity is coming down. It is coming closer to the surface. That's why the sizes of the craters are becoming bigger. And soon you will see that you see the big crater which is gone just now, the big black crater. And it is early morning there at the landing site. Remember that we had landed in early morning time, so the shadow will be longer. And now you will see very soon stabilization of this, because it became vertical. And just stopped at the location. You see here now, you see became stable, right? And now it is searching the best possible landing site. It is found and it started now going down. So it is going down. It is landing. So this is how the actual landing happened on that day. And we are all jubilant. So I was also very happy. So I was over the moon, and this is me very close to the model of the lander and the rover over there. But the whole world was actually celebrating this. And let me play this about.
India has done it. It has become now the fourth country to land a spacecraft on the moon after the US and China and the former Soviet Union. Just moments ago, we're talking this.
India has made space history, becoming the first nation to soft land a spacecraft on the moon's south pole. India has become the first nation to successfully land a spacecraft near the south pole of the moon. The country's PM Narendra Modi has praised the achievement, saying that mission success belongs to all of
spacecraft Chandrayaan-3 is attempting to be one of the first to land on the moon's south pole.
Yes, as the first country in the world to land a spacecraft near the moon's south pole, a moment of history for the country. It was at its final 6 minutes as it descended onto the lunar surface. Let's show you the moment. First of all, let's take
Space Agency is celebrating the successful moon landing of this Chandrayaan-3 spacecraft.
Okay, now India's lunar probe Chandrayaan-3 has landed on the moon south pole. India is the first country to touch down on this part of the moon, which is believed to hold pockets.
We begin with some historic news. India has become the first country in the world to successfully land a craft near the moon's south pole. Prime Minister Narendra Modi was watching the mission from South Africa and congratulated the team back home. Let's take a closer look at what.
So this is how the whole world was celebrating the success of the Indian mission. Of course, we all did also, and I hope all of you who are watching me this lecture would have also seen how we landed onto the south pole of the moon, or very close to the moon. Okay, so what happened after that? There is a rover which is sitting inside the lander, which has to come out and move and do the science, including, of course, the science experiments on the lander. And you see this rover which is in a stowed condition, and there is a ramp which has to come out, on which a 6-wheeled rover has to come out. So this is the activity which you did immediately after the landing. So when the whole nation was actually celebrating, we are very busy in the mission control doing this kind of exercise. And I will show you now that what happened and how we did it. So very soon you will see the lander. You see here. Okay, this is just okay. So this is the lander, and this is the ramp opening. Okay, this is one of the very important activity, because if the ramp doesn't open, rover cannot come out. So rover, and then you will see just now the solar panel will be deployed. You see this. So the ramp was deployed. You see this big ramp, and the solar panel were deployed for the rover, and now rover is actually ready to move down onto the surface of the moon. So how the rover moved out, I'm going to show you very quickly. Just keep watching carefully.
39. नहीं अभी नहीं दिखा
So now the rover will come out. See,
दिखा ना
slowly,
क्या
and it started rolling down.
Hello.
You can see the long shadow. And this is Indian flag seen there when the Ashok has come. It has come out. And this is the time I was holding myself, because I could see very clearly there is a small crater there. And I was worried that as soon as it has come out, it should not go into a crater and create problems. And therefore, I was holding myself in the mission control, thinking that it should hold itself.
Okay.
I will just play it again to make you feel what I'm talking about. So once the rover starts coming down, there was a crater in the front. You see here, this crater, the black. Okay. Oh, not this one. Wait. So we'll do this one. Roll up. Okay. Yes. And this rollout is, see this crater in the front, right? Black structure which is seen. And as the rover is coming down, this crater looks to be very close by. And that's why I was a bit worried that it should not go inside this big crater. But luckily, I was holding myself like this, and then I thought, oh, it has not gone, it has just stopped. Okay. So you see, after this, it just passed this crater. You see this black crater, and you can see the strips of this wheels of the rover moving onto lunar surface, creating a structure which is the path of the wheels by which the rover is moving onto lunar surface. So it passed through, because we found that it is not very deep, it is shallow crater. So it was able to successfully go through. Now after that, I will show you one more movie which will show you how the rover movement is actually happening. Okay. So this will show you the rover movements. See, the rover is moving now in this area. Now it will take a turn. It has taken a turn. So these movements are done because we have to generate power on the rover. And rover power generation is very important because if we don't generate power on the rover will be drained of the batteries. So power is required, and that was all created on the rover
सर्टिफिकेट
by
बनाना
the panel, solar panel, which is attached to the rover. And that was generating power by which rover was
है
operating.
7 तारीख का भी और इसका
So you see here, this is one of the images which is taken by the rover cameras. So there are two cameras in the front of the rover, which is us taking images, sending back to us in the mission control. We are analyzing and then looking whether it is safe to move ahead. And this was a big crater you see over here. It was in front of the rover. And then we said, oh boy, we have to go back because we cannot navigate this. This is quite deep. And as we went back, you see here the rover path, right? So rover is moving through his wheels, and that creates imprints, and we can very clearly see. But I like this. This is the actual image of our Vikram lander taken by the camera on the rover. And you can see very clearly how coolly our Vikram lander is sitting on the lunar surface. And I will zoom this to show you the two instruments, the Chaste instrument and the ILSA instrument, actually sitting onto lunar surface and making measurements. And this activity of deployment of them, we did it on 23rd night or early 24th, I should say. And they were collecting a lot of data for scientists and sending it back to the Earth, to the lander. So rover was also doing science, lander was also doing science, and all the data was coming from the lander, from the rover to the lander and to the ground. And this image is actually, I should say, is the image of a year of or a decade where we see how our Vikram lander is sitting onto the lunar surface. Now I will show you one movie where we were actually moving the rover, trying to find out the best possible way and the direction in which the rover should move. And this was actually to navigate this all, craters and boulders. You see here the movement, this region. It started moving, then we found no, it is not a good way to go. So we rotated the whole rover. The Pragyan rover was kept on rotating till we found that the direction is okay, but the solar panel is facing directly the sunlight. So that was the primary requirement because we need power on the rover to do any movement, and for that we need to see that the solar panel is aligned perpendicular to the sunlight. So a lot of new science came out from these observations, which you see here, the landing site, which we now call the Shiv Shakti, which was named by Prime Minister. And you see the movement of the rover, the Pragyan rover. It went into this direction, came back, went in the other direction. Then we found that there's an issue because the sunlight is not coming proper. So we came back and started going into other direction. That is the westward side. And then we went by quite close to one of these craters, which you see over here, because scientifically we were thinking that this is a good area to explore, and we wanted to see the distribution of various minerals and elements onto lunar surface, and that's why we went in this direction. And finally we navigated and went closer to another crater, and then this is the place where the Pragyan rover is parked now, and the Vikram lander is sitting in Shiv Shakti. Now immediately after we had landed, we take an image from OHRC. You remember I was talking about OHRC, which is the highest resolution, 25 centimeter. So this was an image on the left side taken just before the landing. This is at 2:28 hours Indian Standard Time. And the right side images at late night at 10:17 hours, 10 p.m. And you can very clearly see a white spot there in the center in this yellow box, and that is a lander. So we could also clearly see the lander sitting at the Shiv Shakti landing. One thing which we did after around 1st of September, we found that a lot of science has been done by the rover and the lander. We thought, let us try to do a hop experiment. And this hop experiment was to see how the engines will perform after almost 12 days of landing in this untrained environment of near southern pole of the moon. And therefore we said we will do a small hop, we will lift the lander and move it to another place and just put it down. So all the ramp was towed back, all the experiments were retracked back, and then if you see the difference between the two, you will see that more or less the right and left looks to be similar, but there is small difference. In the bottom you see a black part, which is a new crater which you see. That means there is a movement of the lander from this location. But how it all happened, let me show you very quickly. This is probably one of the last movies. So here you will see a small lift off, so you will see a lot of dust coming out. And very soon you will see it is getting filled up with the dust here. Oh, see here, right now. So a lot of dust is coming out because the engines are firing. And then huge dust plumes. It has gone a little bit up and then again coming down. And it has just landed. Okay, so this is a very unique experiment. And I should say it's a more like a bonus for all of us because it tested a lot of technologies which is required for our sample return missions later. And it was very perfectly done. And after this, we actually deployed the ramp. We deployed various experiments which is there on the lander, and they all performed very well. That shows that we have this capability of actually doing a liftoff from the moon surface itself. Skip this. So there are 5 experiments on board, 3 on the lander and 2 on the rover. And this is the kind of science which is coming out, which scientists are looking at. We know how the seismic activities are happening on the lunar surface with the INSA instrument. We know how the plasma properties are there on the lunar surface, very close to the surface, about 2-meter height. We know how the temperature is beneath the surface, because there's an instrument which you see here, Chaste, which actually penetrated 10 centimeter inside the lunar surface, and this provides us temperature at every 1 centimeter. We also know what is the kind of elemental composition at the lunar landing site using the APXS and the LIPS, and both these instruments were actually sitting on the rover. So as the rover was moving, we were making measurements once the rover is stable, and that has told us something very different what we were expecting. And scientists are now currently working on that. We are looking at the data very carefully, looking at all the calibrations and things like that. And very soon you will hear some new exciting science outputs coming out. Very recently, you must have also heard about the Aditya L1 mission, which had a launch on 2nd of September. And this is how the whole launch site looks like. This is in Sriharikota. That is the Satish Dhawan Space Center in Shah, Sriharikota. And we had the launch on the morning at 11:50 a.m. And this was done by PSLV. Okay, this is not GSLV, Marti or LNV3. So our PSLV is actually a very versatile launch vehicle which can do various kind of launches if the satellite is not too heavy. And after the launch, it is now in its way to reach the L1 point. And the idea behind this Aditya L1, which is to study the sun, is to study the sun from the L1 point. And the L1 point is a point between sun and earth. So if you see this geometry, which is not according to scale, you see earth, it goes around the sun, and there is a point between sun and earth at the line joining the two, which is called L1, which is just 1% away from the earth. Okay, so it is quite far away from the sun. But the advantage is that as the earth goes around the sun, the L1 point is also going around the sun. And that's how you are able to see the sun continuously. Otherwise, if you are going around the earth, there will be a time when it is in the behind the earth and you will not be able to see the sun. Now, this L1 observatory consists of 2 different classes of instrument. One is called in situ and the other one is remote sensing. Remote sensing we are going to do using hard X-rays, soft X-rays, ultraviolet and visible light. And when we talk about the charged particles, which is actually the plasma which comes out from the sun continuously 24/7, we are going to measure it using 3 instruments, Papa, Aspects and MAC. Essentially, we look at the charged particles, like the electrons, the protons, the heavy ionized helium coming out from the sun. And with this whole suite of experiments, we'll try to understand how the corona is getting its 1 million Kelvin temperatures, how the solar wind is getting accelerated, what is the coronal mass ejections, the solar flares which happens, and a lot of information about the plasma distribution of the plasma which is coming out from the sun, the anisotropy, the temperatures, the coupling and kinetics. So this is the whole spacecraft, and you can see all the experiments sitting at different locations. They are all interested to look at the sun, so they are all facing this space, which is going to face continuously the sun. And various instruments have their different locations, the best vantage point from where they can see the sun. And this is going to reach the L1 point in January. About a 4 months travel from Earth to L1 point is there. And currently this mission is en route to L1 point. We have already escaped the Earth's gravity or Earth's gravitational sphere of influence. And on the way, we are also going to make various measurements. Now, in future, what we plan to do, we are interested to go to Venus, which is of course a very important mission because Venus is inside the orbit of the Earth as we move towards the Sun, whereas Mars is in orbit outside. But both these planets are dominated by carbon dioxide. So you see, Mars is dominated by carbon dioxide, Venus is also dominated by carbon dioxide, whereas Earth is dominated by nitrogen and oxygen. So what happened uniquely on the planet Earth and why Earth is so different than its neighbors? That is a $1 million question. And therefore, we need to understand our neighbors, that is the Venus and Mars, to understand the Earth better. And also to know whether there could be circumstances in which the Earth can go to a condition of carbon dioxide dominated atmosphere like Mars. Venus is also very interesting because it is one of the most, what I should say, inhospitable or very rude planet in the sense that the surface temperature is about 800 Kelvin and the pressure is 100 bar. So that means the pressure and temperature is so large that nobody can survive, right, at the surface. But when you go up about 50 kilometers above the surface, there are clouds which is completely engulfing the Venus, and the image which you are seeing on the left top of the Venus is not the surface, it is actually the atmosphere. We can't see the surface of Venus in the visible light. And therefore, Venus is very interesting because we need to know why Venus has gone into this state and whether Earth can also go into that kind of state. Mars, of course, is very important for us to know because Mars, as I was just mentioning, is believed to contain water in the past, and therefore we should know what conditions actually led Mars to come to these conditions, which could happen on the planet. And therefore, we are more interested to go to Venus as well as again to Mars. But this time, the interest is to do a landing on the Mars rather than doing the orbit. We are, of course, interested also to look at the Earth in more detail because we should know conditions on the Earth which may tip, and that time it can go to conditions of Mars and Venus. So, thank you all for listening patiently, and I hope I am well in time for this lecture. Thank you. Thank you very much.
Thanks a lot, sir. Such an engaging lecture. In fact, those video clips you have demonstrated, you have shown during your lecture are really, I mean, something different. I mean, of course, they are there in the website, but we do hardly get to see those things with an explanation, live explanation. And of course, the entire lecture was very informative, very intriguing. Over to Mumbai. If there are questions, if you can
Yes.
please
Yes.
ask, sir. We may take a few questions, I
Yeah.
believe.
Again, sir, thank you very much for such a fabulous talk. And I'm sure all the students who are attending this talk, you have actually inspired them to the next generation of scientists and engineers who will be working for ISRO. And hats off to ISRO for such a great achievement with Chandrayaan 3 and even Aditya L1 mission. Thank you very much, sir. I am Dr. Chintamani Pai. With me, I have Mr. Vishnu Raja Verma. We are from Space Geeks, and I also thank behalf of Indian Space Industries exhibitors, Professor Mathur. And sir, we have lots of questions. Very first, very interesting question we have from Dhruvi, who is asking, are we able to awake rover?
Okay, so you must have already heard what is happening currently. We have not received any signal from the lander, because the primary contact is lander, and through lander only the rover communicates. So we have not yet heard from it, though we are still trying. We have also tried it many ways possible, but we don't know, in case sometimes it may happen. But you should also remember that the conditions in the lunar nights are very hostile. It goes down to something like 50 Kelvin at the landing site. So it is something like minus 200 degree or minus 250 degrees centigrades. And that is the conditions in which all the subsystems of the lander has to survive. It is quite difficult because there is no heat, and all the batteries which was there during the lunar day, which is the 14 Earth day, it will drain out very fast because it has to keep heating the subsystems to keep working. And therefore, we are knowing that it is going to be very, very difficult conditions. But we are thinking in case it comes back to life. So far, we have not heard anything.
Thank you very much. Sir, I have a question. So, based on the location of our lander and rover, what kind of surface studies we have carried out by the rover as of now? And did the photoionization process, does it affect did it even create any challenges while the lander was landing in the communication aspects?
You must have already noticed when I was talking about the landing site was chosen such that we don't have much issues with the boulders and the craters. Okay? That was the primary requirement because we had to do safe landing. Now the second question was, as you are landing, you must have also seen that we did not see much dust after landing.
Right.
You are thinking that couple of hours it will take for dust to settle down, and then only we will start process of basically putting the RAM and then deploying the rover and moving out and doing science. But when we did actual landing, we found that there was not much issue with the dust. In fact, you must have seen the movie of the Hope thing itself. As soon as the engine was shut off, there was no dust nearby. So that means dust is not a big issue at that site. We
At
don't
that
know
site.
about other sites,
Correct.
but at the landing site, we did not find much issue with dust. Now, the question is about the instruments on the rover and what they did. There were two instruments on the rover. One is the laser-induced breakdown spectroscopy, and the second one is alpha particle X-ray spectrometer. Both of these instruments are looking at the elemental composition of lunar surface in terms of elements and molecules. They have found a lot of this. Some of them is already in the social media, which is already released by ISRO, just to tell the public that yes, we are seeing something exciting. But scientists are now working very carefully, looking at all the features, putting together the stories, looking at the calibration curves, looking at the temperature effects, looking at the other issues which has to be taken into account for doing the deep analysis. So that's going on. But I can tell you that the data is very exciting. It is very novel, very new, and the instruments on the lander, the three of them, that is the seismometer, the temperature thermometer kind of thing, which has gone down to 10 centimeter, and the Ramba LP, which is basically a Langmuir probe, which provides us information on the plasma distribution at the landing site. Those have provided us excellent quality data. So we are just chewing them, right? We are just chewing them to take out the juice of them.
Thank you. I can already see the excitement on your face. Thank you very much. We have, sir, one more question. What was the biggest, by Dhruvi, what was the biggest challenge in Chandrayaan 3 mission?
Oh, biggest challenge was actually soft landing. And you must have heard or seen about that during Chandrayaan 2 landing also, we were doing perfectly well, but just about 2 kilometers above the surface, we found there were some anomalies and then we lost the signal, right? So this time we wanted to make sure that we do perfect landing. And we wanted to do it perfectly well. And that's why we took about 4 years, right? After 2019, September. And we did it in August 23rd. So just exactly 4 years we took. But there were a lot of modifications which are required to be carried out, both in terms of the configuration of the engines, the steadiness of the legs, the selection of the landing sites, the tests which are done on the ground to make sure that we will have a perfect landing, the instrument, because it's all autonomous landing, right? So there's no command control given from the ground for that time. Once it has started descending, it has to decide using its own sensor, using its own what you call subsystems, at where we are, where I am, how high I am, what is my velocity, what is my acceleration, how fast I should move down or how slow I should move down. Everything is decided by the onboard computers. So that means the algorithm which is deciding this has to be perfect and meet all the requirements of this autonomous landing. And that is the biggest challenge.
Right. There is one question, I'll slightly modify it for you. Is ISRO planning to send astronaut to space in future? Maybe from the lunar exploration perspective. Of course, you can, sir, also throw some light on Gaganyaan mission.
Of course, you must have already heard about Gaganyaan mission, that India is planning to have Indian astronauts to go to space. And the plan is to send 2 astronauts into space very soon. So that mission is called Gaganyaan. ISRO is working on it, but we have to work it in a perfect way, like the Chandrayaan 3 land, because it is not one-way traffic, na? That one-way ticket, you go up and then don't come back, right? It has to come back safely, right? So it is like a landing back on the Earth, right? So that's why there's a lot of technology which is required, and that has to be proven. It has to be tested, validated before we actually undergo this kind of missions. We are planning to have the 2 what you call test flights of the Gaganyaan before we actually send humans, right? Because first of all, we have to also see that things goes up very well and comes back. Because when the humans are going, there are a lot of other changes which is required for the safety of the human. How do they live in that conditions? How do they breathe? How do they work out, right? And then they have to be brought back safely. So there are technologies which is required, which has to be completely tested and validated before we undertake. So very soon it's going to happen. Maybe another couple of years, we will have the Indian astronaut going to space. And I will request all the children who are listening to me, get prepared, to become astronauts in future.
Sir, one more. Since India has now become part of Artemis Accords, so what kind of, with the great success of ISRO with Chandrayaan 3 and Aditya L1 mission, what sort of global cooperation we are looking at with the lunar exploration and beyond?
Artemis Accord is actually some kind of association, you can say, because when you're going to space, it's a quite costly affair, right? And if many countries are going to the moon, which is currently happening, right? Because India is going, US is going, Russia has already recently gone, you must have heard about that, Japan is going, China is going, Korea is going, Israel is going, right? So there are many countries which are interested to go to the moon, but then what, right? So if you have to have a long-term planning, then you have to join together. So at the planet Earth, we all know, right? There are countries, but at least at the moon, we should go together and work together, right? So that's what the cooperation is, that we should have a space cooperation among various countries, and which will help us to yield much better returns than individually doing efforts, because the efforts are quite costly. And therefore, the Artemis Accord is actually, if you look in the essence of it, it is like cooperation in space and the exploration of the moon, which is going to be beneficial for the humanity.
Thank you. I think if we have no further questions, sir, we thank you very much, sir, for joining all the way from Space Applications and from the Physical Research Laboratory, Ahmedabad. And I thank you behalf of Nehru Science Center, who gave us opportunity, platform to organize, to celebrate Space Week. And I also thank Manjula ma'am, Rajesh, and all the staff of Nehru Science Center who have been working behind the scenes to make things go smooth. I thank all of them, and I also thank Arnab Chatterjee sir, joining all the way from Director in charge Nehru Science Center, joining all the way from Nagpur. And sir, again, it was very enlightening talk for all of us. I can see the students are already inspired, and as you said, yes, we will expect next future astronauts from them. And thank you very much, sir.
We have put up one Google form.
Yeah, Manjula ma'am, over to you.
We have already put a link for the filling up the Google form. Please, for your feedback and also for the certificates, we will be sharing the digital certificates with all the participants who have joined today. So all participants can just see the chat box. There is a link for the Google form. You can click on the link and there will be a Google form. You'll have to fill it up. Once you fill it up and submit it to us, that's for the feedback of the lecture, and also for sending you the certificates. So please see the chat box for the link. And well, that's all we for
Okay, so
today's
thank you
this particular
everyone,
session.
and thank you.
Thank you so much, sir.
Thank you, sir.
Manju,
It was very nice
congratulations
talk, sir.
and
We all